Hi!
It's Cañete,
Yes.
Manghano,
and Mayo
From STEM Atom.
For today's activity, we're going to showcase our basic engineering skills and knowledge to observe the phenomenon of Kirchhoff and Ohm's law.
We already prepared everything and constructed this circuit in order for us to use in this activity.
So here is the constructed series parallel circuit, which includes 4 resistors, 1K ohms, 680 ohms, and two 470 ohms.
To start with our equations, here are the given values in this series parallel circuit. There are 4 resistors. Resistor 1 with 1K ohms, resistor 2 with 680 ohms, resistor 3 with 470 ohms, and also 470 ohms for resistor 4. Lastly, we have a battery with 9 volts.
Next is to find the total parallel resistance of R2 and RST1. Again, RST1 is the sum of our resistors 3 and 4. To find our RPT1 or total parallel resistance of R2 and RST1, we are going to use the formula R2 times RST1 divided by R2 plus RST1. Next step is we're going to substitute the values of the given equation. So, 680 times 940 divided by 680 plus 940, we have a total value of 394.5,679,012 10 millionths ohms. Since we have solved for resistors 2, 3, 4 and combined them into 1 as our RPT1, we can now solve for RST2, which is R1 plus RPT1. With this given equation, we are going to substitute the given values. 1000 ohms or 1K ohms plus 394.5,679,012 10 millionths ohms. We are going to have a total sum of 1,394 and 5,679,012 10 millionths ohms.
Using our RST2, we can now begin to solve for the total current or IT. To find this, apply the formula total voltage over RST2, total voltage being 9 and RST2 being 1,394.5679012, which gives a total current of 0.0064536118981 amperes. Current flow in resistor 1 is equal to the total parallel current, which is also equal to the total current.
Moving on, we now have to find the voltage taken by resistor 1. We will call this V1 and the formula will be R1 times IPT1. After substituting the values and solving, we will see that the value of RV1 is equal to 6.453611891 volts. To find the total parallel voltage of RVPT2 that involves resistor 2, 3, and 4, we must multiply the value of RPT1 and IPT1. That gives us a VPT2 of 2.54638881017926 volts. Kirchhoff's law states that voltage in parallel circuits are the same, hence V1, VST1, and VPT2 have the same value of 2.54638881017926 volts.
Therefore, the current in R1 is 0.0064536118981 amperes, while the voltage of R1 is 6.4536118981 volts. To prove that all the voltage in parallel circuit are the same, we have to find the current used in resistor 2, or what we call our I2. I2 is equal to E2 over R2. Solve and substitute and we'll get 0.00374468883849 amperes.
This time, we have to calculate the total current that flows in RST1, which is going to be our IST1. IST1 is equal to VST1 over RST1. Substitute the values, then we're going to have 2.54 6388101796 volts divided by 940 ohms. Then we're going to have an answer of IST1 of 0.0027089235125 amperes. To check if the values of the voltages are consistent with each other, let's use the previous values to solve for V2 and VST1. V2 is equal to R2 times I2, so that is 680 ohms times 0.0037446883849 amperes. Then we're going to have an answer of V2 of 2.5463881011732 volts. VST1 on the other hand is equal to RST1 times IST1, so that gives 940 ohms times 0.0027089235125 amperes. Then we're going to have a result of VST1 of 2.54638810175 volts. This proves that our solutions are correct.
Next, we have to solve for V3. According to Kirchhoff's law, current consumed by resistors in a series circuit should be the same, and since R3 and R4 belong to the series part of the circuit, their values must be the same. To find V3, we should multiply R3 with the value of I3. So, we have 1.273194050,875 volts. Then, we do the same process to solve our V4. So, as seen, it's the same value as V3.
As checking, we have to solve for VST1, or the total series voltage consumed in RST1, which is equal to the sum of V3 and V4. Substitute and solve, and then we'll see that our VST1 is 2.54638810175 volts.
For the redrawn series parallel circuit program, here is the diagram with the specific location of the voltmeter for resistance 1, resistance 2, resistance 3, and resistance 4. The red line represents the positive test probe, while the black line represents the negative test probe. For the other redrawn series parallel circuit program, here is the diagram with the specific location of the ammeter for resistance 1, resistance 2, resistance 3, and resistance 4.